Hello, good morning, everybody, and welcome to our Mathematics 9 class. I know it's a long delay, so we have so much to catch up. And today we'll talk about lesson 6.3. It is about the similarity of triangles. In the past lessons, we have talked about proportion. We've said that similar objects have the same shape and their sizes are proportional. In the previous lesson, we have talked about similar polygons, and today we'll talk more about similarity of triangles. Before we go further, let's first recite today's memory verse, found in Genesis 9, verse 6. In the New International Version, it says, "Whoever sheds human blood, by humans shall their blood be shed. For in the image of God has God made mankind." We are created similar to God's image. So you must not feel ugly or discontented, right? Because you see, we are being created in the image of God. Your VCA boosters is to learn the song Be Like Jesus. Here's a music sheet that you can see on your screen. And there's also a YouTube link in your MVCA boosters. Now, what does the song remind us? Let me sing the refrain part. It says, "Be like Jesus, this my song, in the home and in the throng. Be like Jesus all day long. I would be like Jesus." What does the song remind us? At the end of today's class, you'll be able to prove the conditions for the similarity of triangles. We have the SAS Similarity Theorem, the SSS Similarity Theorem, AA Similarity Theorem, right triangle similarity theorem, and special right triangle theorems. And we need to apply these theorems to show that the given triangles are similar. And lastly, we solve problems that involve triangle similarity and right triangles. And here's your venture activity for today. What is your strategy? Do you know the height of the flagpole without directly measuring it, and just by using your own height and both of your shadows? Now, what is your strategy? Today, we'll talk about similarity of triangles. When do you know that triangles are similar? And we have some theorems. The first one is the AA Similarity Theorem. The AA is a shortcut for angle-angle. That's for you to remember, angle-angle. It means that if two angles of a triangle are congruent, it means they have the same measure with the other two angles of another triangle, then the two triangles are similar. Example, angle U is congruent to angle H, and angle V is congruent to angle Y. Therefore, triangle LUV is similar. We only have one like this, similar to triangle WHY. Second theorem, SSS Triangle Similarity Theorem. SSS stands for side, side, side. Sorry. It means that if the lengths of two sides of two triangles are proportional, then the two triangles are similar. In our previous lesson, we have talked about the scale factor. That's the proportional ratio of the two polygons. So if the scale factor is working for all sides, then we say that two triangles are similar. Example, PR is proportional to SU. PQ is proportional to ST. and QR is proportional to TU. Therefore, triangle PQR, that's from 2 to 3, right? PQR is proportional or similar to triangle STU. So we have the AA, we also have the SSS. The third one, we have the right triangle similarity theorem. The altitude to the hypotenuse, so for example, this is the hypotenuse because this is the opposite of the right angle. This is called the altitude to the hypotenuse of a right triangle forms two triangles similar to each other, and these two triangles are also similar to the main right triangle. So here we say that REM is similar to EYM, and REM is also similar to RYE. Now we have some special properties of right triangles. When you draw an altitude to the hypotenuse, like this one, here are some properties that would apply. First, the length of the altitude is a geometric mean between the segments of the hypotenuse. So it means that this one, EY, is a geometric mean of MY and YR. Next, each leg is a geometric mean between the hypotenuse and the segment of the hypotenuse. Again, each leg is a geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So for example, in this illustration, we see that W is a geometric mean to U and V. Another, R is the geometric mean to T, that's the whole hypotenuse, and its segment, and U. S, another hypotenuse, another leg, is a geometric mean to T and V. Let us have some examples. Exercise number 1. We state if the pair of triangles are similar. Then we state the theorem of similarity that applies. That's the first one. Angle A is 35. Angle D is also 35. Angle B measures 75 degrees, while angle F measures 70 degrees. Let me first annotate. If you check, the sum of all the angles in a triangle is 180 degrees. So if this is 75 and 35, it means that angle C is 70 degrees. Also, angle E will measure another 75 degrees. If you see, two angles are similar. So we say that triangle ABC is similar to triangle where? DEF. What's the reason? What's the theorem? We have the AA triangle similarity theorem. Let's go to the next one. We have 84, 48, and 72. The other, 12, 8, and 14. So with this one, the given are 3 sides. So we will check if the SSS triangle similarity theorem is being applied on this. Now let's start with this one. Ready? The smallest, the shortest side of the other, divide it by the shortest of the other. So it's 8 over 48. We see the scale factor We divide both by 8. So we have 1 over 6. That's the scale factor. But then we check. How about the second side? 12 over 84. Is 12 over 84 having the scale factor of 1 over 6? Let's check. 12 over 84. You divide both by 12. Is 1 over 7. Therefore, the sides are not proportional. So we say the two triangles are not similar. Let's go to the third one. Here, we have 9, 9, and this one. The next, 27 and 27 for the other. Now, you see, both are right triangles, right? And if you check, both are right triangles, so they have the same for A. If you see, this is an isosceles right triangle because that's 9 and the other is 9. In the previous lesson, remember that isosceles triangles have the same base angle measures. So this will be 45 degrees and 45 degrees. The same is true for the other triangle. It's 27 and 27. So this can be 45 and another 45. If you check, we have two angles that are similar, that are congruent to each other. So we say that triangle BAU is similar to triangle CAB. What's our reason? We can still have the AA triangle similarity theorem. You might ask, ma'am, is it the only way for us to prove? No, actually you can use the right triangle theorem. It's up to you on what theorem you're going to prove using the similarity. Let's go to the next one. We first clear this up. Now let's go to the next one. We still have the next pair. We still need to state if the pair of triangles are similar or not. Let's have the first one. What's the given? If you see the given, that's 16 and 16, 39 and 40. Remember, these two are vertical angles. Therefore, since they are vertical angles, then their measure are the same. 16 and 16, they are equal. Therefore, D is equal to E. But if you see on the other side, these two are not equal. Therefore, you could not show that there are two equal angles. So we say that these triangles are not similar. Let's go to the next one. We have three given sides, 6, 5, 8, and 42, 35, 56. We'll check if the three given sides are proportional. So you'd like to check the SSS Triangle Similarity Theorem. So let's have the shortest side. That's 5 over the other shortest side, over 35. The scale factor is 1 over 7. Let's check with the second one. 6 over 42. Yes, it's still 1 over 7. The other one, 8 over 56. That is still 1 over 7. Let's check. So these 3 sides are proportional. We say triangle from the smallest here to the biggest. EDF is similar to triangle to smallest to the biggest. Here, UTV. EDF from small to big, and UTV. Now, what's the reason? Sorry. Oh, how do I exit this? The reason for this is SSS Triangle Similarity Theorem. Let's go to the last example. We have angle T is congruent to angle J. Angle K is congruent to angle U. So we say that 2 triangles are similar. So triangle from the other with 2T UV is similar to triangle JKL. And our reason is AAA, Triangle Similarity Theorem. That's it. Now, we'll go to the next exercise. We're down to the last 4. The triangles in each pair are similar. We find the missing length. So you see here, that's 35 degrees, and this is 28. So how do we do that? There's one way. Actually, the sides are proportional. So we say that LJ is proportional to side RP. And KJ is proportional to side QP. LJ measures 28 over 42. So we can have it equal to KJ, sorry, it's not KL. KJ over 33. Or another way is you can divide 28 over 42 first. That's going to be 7 over, divide both by 7. So 4 over 7. It's 14 by 21. We first check. Sorry, 4 over 6 there. Oops, it can be 2/3. 28 divide 14 is 2, and 42 divide 14 is 3. So our scale factor is 2/3. KJ over 33 equals 2/3. We can do cross multiplication for them. We check. Sorry, I'm not bringing my pen, so I find it hard to write. Equals 2/3. We can cross multiply them. So we will have 3 KJ is equal to 2 times 33. The 3 KJ is equal to 66. We divide both sides by 3. So we have KJ is equal to 22. If you check, 22 over 33 is still 2/3. So the measure of KJ is 22. Let's go to the next one. Still the same. Both triangles are similar. We find the missing length. Here, we have UV and UT. Check. Then we have ML and KL. Based on the drawing, if you see it, she's smaller here. UT is proportional to ML, while UV is proportional to KL. The one that is given is UV and KL. That is 60 over 130. So our scale factor is 6/13. Now, we write it. So let's check with UT and ML since it's missing. UT over ML is that's 117. That should be equal to 6/13. Now we cross multiply them. We have 13 UT is equal to 6 times 117. So we have 6 times 117. We have 13 UT is equal to 702. We divide both sides by 13. So we have UT is equal to 54. If you check, 54 over 117 is still 6/13. If you have questions, feel free to message me in Telegram. Let's go to the next one. Ready? The triangles in each are similar. We find the missing length. Now, based on the figure, I'm just checking the figure which is smaller here. ST is proportional to BC. Oh, no, not that one. The smaller side to DC, while SR is proportional to BC. Now, the first one is given. So we have 70 over 50. Our scale factor is 7/5. So this time we need to write this one and equate it to our scale factor. So we have 11 minus 4, 11x, 11x minus 4 is equal to 60. That's equal to scale factor 7/5. We will cross multiply them. So we will have 5 times 11x minus 4 is equal to 7 times 60. We will distribute 5 times 11x is 55x. 5 times -4 is -20 is equal to 420. We transfer -20 to the other side. So we have 55x equals 420 plus 20. So we now have 440 on the right-hand side. We divide both sides by 55. So our x is equal to 8. If you want to check what is the missing length, because we are not looking only for the variable, so we will substitute. Remember, SR is equal to 11x minus 4. So our x is 8 minus 4. You have 88 minus 4. SR is equal to 84. If you check 84 over 60, that will, you divide both by 12, is equal to 7/5. Questions? Now let's go to the last example. Let's have the last example. The triangles in each pair are similar. We find the missing length. Okay, let's start. This is the short one. So VU is proportional to SU, the other short one. While VW, the longer one, is proportional to ST. The longer one has complete measurements. So VW is 88, ST is 24. So wait for a while, almost there. We divide both sides by 8, so we have 11/3. Now, we write the other one. We have VU. VU is 5x plus 11 over SU that's 18 is equal to our scale factor 11/3. We cross multiply them. So we will have 3 times 5x plus 11 is equal to 18 times 11. Let's distribute it. 3 times 5x is 15x. 3 times 11 is 33. 18 times 11 is 198. We transfer 33 to the other side. So we have 198 minus 33. Subtracting them, we have 165. We divide both sides by 15. So our x is equal to 11. Since we're looking for the measure of VU, which is 5x plus 11, we'll substitute it. Our x is 11. So we have 55 plus 11. So VU is equal to 66. If you have any questions, feel free to message me in our Telegram group chat, or you can send me a private message. Thank you for joining me today, and I'll see you in the next video. Bye-bye.